In this video, we're computing a definite integral, the integral from 2 over pi to 4 over pi of cosine 1 over x divided by x squared. And we're going to do this first informally by setting up the chain rule backwards, and then we'll follow it up with a formal u substitution. So for the informal approach here, basically we just have to recognize that the derivative of the interior function is part of the integrand, and the derivative of 1 over x is negative 1 over x squared, so we're almost there. And we're going to supply that factor of negative 1 on the inside of the integral, and then multiply by negative 1 on the outside to compensate for it. And now that we have the derivative of the interior function sitting there, we recognize the effects of the chain rule, and we can just guess the antiderivative, which is the sine of 1 over x. Now we sub in the upper limit, and 1 over 4 over pi is pi over 4, so I have a sine of pi over 4. And my lower limit is similar, I end up with a sine of pi over 2. Now we sub in the values of the sine function at these special angles. Sine of pi over 4 is root 2 over 2. Sine of pi over 2 is 1. And finally, we'll distribute the factor of negative 1 into that binomial. And I end up with a final answer of 1 minus square root 2 over 2. Now in the formal approach, we still have to recognize what that interior function is, and we'll call that u. And we also have to see that basically the derivative of that is hanging around in the integrand, otherwise it's not going to work. So I let u equal 1 over x, and then I find the differential of u. That requires differentiating 1 over x, which again differentiates to negative 1 over x squared. And I get negative 1 over x squared dx. I can also transform the limits of integration here. So when x is 2 over pi, u is 1 over x, which gives me the reciprocal of 2 over pi, or pi over 2. And when x is 4 over pi, u is pi over 4. Now because I already see my 1 over x squared dx sitting in the integrand, there's the x squared in that denominator and the dx out on the end. If I just throw a minus sign into the integrand, I'm going to find du. And that's basically what we did in the informal approach. I have my negative 1 over x squared out there, and then I have a dx, and those combine to give me du. And then the cosine of 1 over x is going to become the cosine of u. I'm going to transform the limits of integration to the u limits in this step. And again, negative 1 over x squared dx, that just gives me du. And the cosine of 1 over x is just a cosine of u. Then I guess the antiderivative of cosine u, which is sine u. And we evaluate across the limits of integration. And I end up in the same spot I did before in the informal approach. And this simplifies to 1 minus square root 2 over 2. And the answer agrees. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left. Or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.